Welcome back to another video. Have you ever wondered about the technology that makes self-driving cars a reality? Or how Google Translate can translate languages efficiently? All of this and more is possible due to deep learning. So what is deep learning? And why is it gaining so much popularity in scientific computing? What are the other applications of deep learning technology? What is the difference between deep learning and machine learning? Well, stick till the end of the video to find out. We will also be discussing neural networks in this video. Before moving forward, please take a moment to hit the like button and smash that subscribe button and turn on bell notification so that you don't miss any updates. Stay tuned. So what is deep learning? Deep learning is a subset of machine learning, which itself is a subset of artificial intelligence. To quickly recap, artificial intelligence is a branch of computer science that deals with simulating human intelligence in machines, that is, giving machines the ability to think. Machine learning enables computer systems to learn and improve from experience without being explicitly programmed. This is achieved by training algorithms with data. If you want to know more about machine learning, do check out my video on machine learning. I'll add a link to it in the description below. Deep learning models utilize artificial neural networks that are inspired by the biological structure of the human brain, the neurons. An artificial neural network, or ANN for short, is a collection of nodes called neurons. The adjective deep in deep learning is often used to represent the multiple layers in the network that helps to learn various aspects of the data. So what about a single layer neural network? This is called a perceptron and is much similar to the neuron in the brain. Let us look at a biological neuron for understanding this concept further. A biological neuron has three parts, namely dendrites, cell body or soma, and the axon. Dendrites are tree-like extensions at the beginning of the neurons that receive information from other neurons. The information from the dendrites is then passed on to the cell body or the soma. The input signals are then combined and transmitted to the axon. When the strength of the signal exceeds the action potential of the axon, the signal is fired down the axon. Now let us look at an artificial neuron. A single layer neural network or a perceptron represents the most simple form of neural network and consists of an input layer and an output layer. A multi-layer perceptron or neural network will consist of an input layer, a hidden layer and an output layer. Single layer neural networks or perceptrons are part of the class of feed-forward networks and are mainly used as linear classifiers. The working of a perceptron is as follows. The input to the neural network is fed to the neurons at the input layer. All the inputs x are multiplied with the corresponding weights w. A summing function is then used to add all the input weights. This value is known as the weighted sum. A bias value may be added at this stage and the weighted sum is then passed to the activation function. Why do we add a bias value? Bias values are used to adjust the output value along with the weighted sum of inputs in a way that best fits the given data. Activation functions are functions used to determine the output of a neural network by normalizing the input in the range between 1 and -1. They work by activating or deactivating the neurons to get the desired output. To know more about activation functions in neural networks, you can check out my previous video on activation functions. I'll add a link to it in the description below. Perceptrons are usually used to classify the data into two parts and hence the name linear binary classifier. This is the basic working of a perceptron. Now that we have understood the working of a perceptron, let us look at the working of a neural network with an example. The input to a neural network will be an image of a handwritten digit from the MNIST dataset. Now if you are getting started with neural networks, it would be helpful to get an idea about the MNIST dataset as it is an extremely popular database for people who want to try machine learning and pattern recognition on real-world data. This dataset is pre-processed and formatted, making it easy to understand and use. So what is the MNIST dataset? The MNIST dataset is an acronym that stands for Modified National Institute of Standards and Technology. The MNIST dataset is mainly used to perform digit recognition using CNN. More on CNN in a later video. The MNIST dataset consists of 28 by 28 pixel grayscale images of handwritten single digits between 0 to 9. It has a total of 70,000 images in 10 classes ranging from 0 to 9. Okay, so getting back to a neural network. An image from the MNIST dataset is given as input to a neural network. The image consisting of 784 pixels is fed as input to the neurons in the input layer. Each neuron is connected to every other neuron in the next layer. Every neuron has a weight associated with it. The weighted sum is then sent as input to the hidden layer. Each neuron in the hidden layer adds value to the weighted sum called the bias value. This sum of bias value and weighted sum is then passed on to an activation function which then controls the firing of the neurons. The neurons are activated if the value is above a certain threshold and the data is transmitted to the next layer. This process of transmitting data from one layer to another layer is known as forward propagation. This process continues till the output layer, and the output of the neural network will be determined by the neuron that has the highest value. The output layer is the last layer in the neural network. The output of the neural network will be a probability value of the class. For example, it may give us a high probability of one class and low probability of the other classes. So the highest probability is taken as the output of the neural network. So what if the neural network gives us a wrong probability score? This is why we train the neural network. When we train the neural network, the actual output is also fed along with the input to the neural network. The actual output is then compared with the predicted output to determine the error value. This information is transmitted back into the network so as to adjust the weights of the neurons. This method of transmitting information back into the network is known as backpropagation. This series of forward propagation and backward propagation continues until the error value becomes very low and the network predicts the output correctly. This is when the training process stops, and this is the basic working of a neural network. Now that we have an idea about deep learning, let us look at what makes deep learning different from machine learning. Machine learning techniques use algorithms to parse the data, learn the data, and make decisions from information learned from the data. Whereas, deep learning uses artificial networks that can learn and make decisions on their own by automatically extracting patterns from the data, thereby reducing human intervention. Another difference between the two methods is that deep learning models require more data compared to a traditional machine learning model. Let us now look at the different applications of deep learning. Self-driving cars. Self-driving cars such as Tesla use deep learning to detect objects around it, navigate and control the car, and also to plan the route from point A to point B. Deep learning is also used by self-driving cars for localization, that is, to define its position in the world with high level of accuracy. Customer service. Many companies started incorporating deep learning technologies into their customer service products such as chatbots. Traditionally, chatbots use natural language processing to provide customer responses. However, more sophisticated chatbots started using deep learning technology to provide human-like responses. Healthcare. The healthcare industry is another industry that has benefited greatly from deep learning technology. Healthcare industry uses deep learning for medical image classification, helping radiologists and specialists analyze images in very less time. Facial recognition. Many of the smart devices such as smartphones, laptops use deep learning to identify and detect the face of the user. Do you know some more applications of deep learning technology? Let me know in the comment section below. Some of the commonly used deep learning algorithms are artificial neural networks, convolutional neural networks, recurrent neural network, deep neural network, deep belief network, restricted Boltzmann machine, long short-term memory, and autoencoders. Some of the popular deep learning frameworks include TensorFlow, PyTorch, Keras, DL4j, Caffe, Microsoft Cognitive Toolkits. That brings us to the end of this video. Hope you got a basic understanding about deep learning technology and neural networks architecture. Don't forget to drop a like and share this video if you found it useful. Also, please hit the subscribe button and turn on bell notification so that you don't miss any updates. Thank you for watching and see you in the next video.